You're listening to SpaceTime with Stuart Gary.
Astronomers from the University of Arizona have provided additional support for Planet 9's existence and also narrowed the range of its parameters and location. The team, led by Renu Malhotra, found that the 4 Kuiper Belt objects with the longest known orbital periods all revolve around the Sun in patterns most readily explained by the presence of a distant planet with about 10 times the mass of the Earth. Malhotra's calculations also show Planet 9 should complete an orbit around the Sun roughly every 17,000 Earth years. Its apogee, or furthest orbital position from the Sun, would place it over 660 astronomical units out from our local star. An astronomical unit is about 150 million kilometres, the average distance between the Earth and the Sun. Scientists think most objects in the Kuiper Belt dance mainly to the tune of the giant planets, Jupiter, Saturn, Uranus and Neptune, influenced by their gravity, either directly or indirectly. However, there are some known Kuiper Belt objects that are simply unlikely to be significantly perturbed by the known giant planets in their current orbits. These extreme Kuiper Belt objects, as they're called, all have extremely large orbital eccentricities, which bring them relatively close to the Sun at one point in their orbital journey, only to swing far out into interstellar space at another point in their long elliptical orbits. When the team analysed data from these most distant Kuiper Belt objects, they found something strange. It suggested that these distant worlds were all in some kind of resonances with an unseen planet. The peculiarities of the orbits of these extreme Kuiper Belt objects had simply gone unnoticed until now. The team found that the orbital period ratios of these objects are close to the ratios of small whole numbers. A hypothetical example would be a single Kuiper Belt object travelling around the Sun once, while another takes twice as long, or 3 times as long, or even 4 times as long, and so on, but not, say, something like 2.7 or 4.3 times as long. These sort of ratios arise most naturally if the extreme Kuiper Belt objects' orbital periods are all in small whole number ratios with a massive planet, which would help stabilise their highly elliptical orbits. The findings bolster previous work that showed 6 of these objects travel on highly eccentric orbits, whose long axes all point in the same direction. This clustering of orbital parameters of the most distant Kuiper Belt objects suggests a large planetary-sized body shepherding their orbits. The new study provides more specific estimates for the mass and orbit that this planet would have, and more importantly, constraints on its current position within its orbit. In other words, it gives scientists an idea of where to look. The team's calculations suggest 2 likely orbital planes for the planet. One is moderately close to the orbital plane for the solar system as a whole, and close to the average orbital plane for the 4 extreme Kuiper Belt objects at about 18 degrees. Meanwhile, the other's a far steeper orbital plane, inclined to about 48 degrees. While the new findings provide additional support for the idea of potential Planet 9 and lay out possible orbital scenarios, it's still not definitive proof of the planet's existence. For one thing, the very far and faint Kuiper Belt objects haven't been observed for very long, and given their minuscule apparent motion along their immensely long orbital journeys around the Sun, the estimates for their closeness to whole number ratios for orbital periods comes with heaps of uncertainties that can really only be narrowed down through more observations. The long orbital timescales in this region of the outer solar system could also allow formerly unstable orbits to persist for very long timescales, possibly even as old as the 4.6 billion year age of the solar system, without the help of any orbital resonances. In this scenario, orbits whose orderly parameters appear as testimony to the stabilising influence of an unseen Planet 9 may in fact be in the process of deterioration, but simply haven't been observed long enough for it to show. Again, it's a case of needing further observations and studies into the dynamical lifetimes of non-resonant planet-crossing orbits in far regions of the outer solar system.